Okay, good morning, all of you. So today we will start some basics of humanoid robots. As the name indicates, humanoid robots, what is a humanoid robot? Or what is the difference between humanoid robots and autonomous robots? As the name indicates, humanoid robots are designed to resemble human body structure. The robot looks exactly like a human being. The robot is having this arm, hand, leg, head. That means the robot is designed in such a way that it resembles the human body structure, and the robot will mimic the behavior of human beings. At the same time, the autonomous robots, the autonomous robots are capable of performing various tasks without human intervention. For example, assembly of a car. There are autonomous robots. Those robots are performing various tasks such as welding, assembling. So they are giving some tasks. But humanoid humanoid robots are basically the structure will be different. The shape of the humanoid robots is like exactly like a human being, and the robot will mimic the behavior of human. I will show you one example of a robot from Boston Dynamics. In the screen, you can see this is a robot from Boston Dynamics, and the name of the robot is Atlas. Actually, Atlas is a name for multiple robots from Boston Dynamics. This is a company in USA. So first we will watch the video of Atlas from Boston Dynamics. So the one main advantage of this robot is the dynamic stability. Okay. If you want more information, you can refer the Boston Dynamics website. Go to Boston Dynamics and you will get more information about this. Quickly, I will give a small information about this robot. This robot is a dynamic balancing robot. That means whatever be the environment, the robot will be balancing his body or balancing his sorry sorry balancing his structure by monitoring real time. The robot will monitor real time, and automatically the robot will uh, s- uh, 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 there is no stability issue. There is no stability issue because of the dynamic balancing. Because real-time monitoring is available, and because of that, there is no stability issues. And another thing is that the robot can rotate. The robot can rotate his body. Also, there is a rotation mechanism at the head. So head rotation mechanism is there. Using that head rotation mechanism, the robot will be able to rotate his head, and also the robot will be able to rotate his body also. So there is no stability issue. The robot will be easily able to walk. The robot will be easily able to rotate his body. The robot will be easily rotate his head and walk like this. So from this video, you can, one of the main characteristics of humanoid robot is the bipedal locomotion. Bipedal locomotion means walking on two legs, exactly like human beings. The robot will be able to walk like human beings. The robot will be able to walk like human beings. So This is one of the characteristics of humanoid robots, bipedal locomotion. And in this video, you can see the robot is having arms, legs, hands, everything is there, so that the robot can easily manipulate different types of objects. So the arms and hands looks like exactly like human beings, and there are various sensors, sensory systems such as vision, touch, audition. So because of that sensory system, the robot will be able to mimic the human senses. And of course, the robot will be able to interact naturally with the human beings. For example, if two humans are communicating with each other, same way, in same way, like same way, this robot will be able to communicate with other human beings naturally. So these are the characteristics of humanoid robots: bipedal locomotion, human-like arms and hands for easily manipulation of various types of objects, and sensory system helps the robot to mimic human senses, and the robot will be able to interact naturally with the human beings. So the basic difference between humanoid robot uh, and autonomous robot is that autonomous robot is purely for various tasks. So the main focus is task oriented. So, but the humanoid robot, the robots emphasize human-like form and interactions. Next, I will show you some history about the robotics starting from 1920. So there is a robot called Elektro. So first of all, I will show you the image. So this is a robot named, and the name of the robot is called Elektro. This was developed in the year 1920. This was one of the early humanoid robot with different capabilities. Let us see what are the abilities of this robot. So this robot was developed in the year 1930. So this robot was developed in the year 1930s. And what are the key features and significance? This is a 7-foot tall steel framed robot with a humanoid appearance. That means it looks like a human being, resembling a streamlined model of a man from Mars. And this robot will be able to respond voice commands. This robot will be able to walk, speak, and even smoke a cigarette. So this was one of the early humanoid robot with simple speech capabilities. This was happened in the year 1920. Then 1973, there is a robot called a WABOT. This is a robot called WABOT 1. This was developed in the year 1970. This was the world first anthropomorphic robot, and this robot will be able to walk, talk, and responding to speech. This was created uh, uh, by the scientist at Waseda University in Japan. This was a significant step forward in the field of artificial intelligence and robotics. WABOT 1 can communicate in Japanese and measure distances and directions, and this robot will be able to grip and transport objects. These are some of the images showing the WABOT robot developed in the year 1973. This was the first full-scale humanoid robot with limb control and vision. Then another robot is ASIMO. This is from Honda company. Yeah, this robot was developed in the year 1997. This was developed from the company Honda. and this is an advanced humanoid robot, advanced bipedal walking, running, and human interaction. So from this image, you can see that this robot will be able to, yeah, from this image, you can see the robot will be able to grip, take objects, and pour this juice into a glass like that. And also the robot will be able to play games like this, and the robot will be able to interact with people's human interaction is possible, and the robot will be able to walk, the robot will be able to run, etc. So this is an advanced bipedal walking robot from Honda company, and the name of the robot is ASIMO. Another robot is called HRP series. This was developed in 2000. HRP series robot. HRP series robot was developed in the year 2000, and these are humanoid robots designed for various research activities or research purposes. And the latest one, 2010 Atlas Boston Dynamics. I already uh, show the video. Yes, and this is this robot. The name of this robot is called Atlas. This was developed in the year 2010. This is the world's most dynamic humanoid robot, and this is fully electric. Previously, it was hydraulic, but now this is fully electric, and this is a dynamic, world's most dynamic humanoid robot. And this robot is designed for real-world applications. So dynamic balancing and complex locomotion in rough terrain is possible in Atlas by Boston Dynamics. The name of the robot is Atlas. So actually, Atlas is a name for multiple robots, and the name of the company is Boston Dynamics, and it was developed in 2010 by incorporating artificial intelligence, dynamic manipulation, and whole body control. So I will show you one more video. Yes, of Atlas. Okay, so that's all about some history about the humanoid robot, starting from Elektro, WABOT, ASIMO, HRP series, and finally Atlas from Boston Dynamics. When we are going to create a model, The humanoid robot is modeled as a system of rigid links connected by joints. And each joint typically has one or more degrees of freedom. That means the moment. Sometimes the degrees of freedom will be one, sometimes the degrees of freedom will be two or more degrees of freedom. The model includes parameters such as the length of the link, the type of joint, and the limit of the joint limits. These are the parameters when we parameters we should consider when we will create a humanoid robot model. Once the robot is designed, then how this robot is moved from one location to the another location. So that is locomotion, how locomotion is happening. And another thing is that how the robot is able to balance. Okay, I already mentioned this Atlas robot is basically using a technique called dynamic balancing. That means real-time monitoring and balance the entire system. So there is no stability issues. As I already mentioned, these are humanoid robots, and these robots are typically move from one point to another using legged locomotion, that is called bipedal locomotion, often mimicking human behavior, bipedal walking. That means walking using two legs. Humanoid robots also walking with the help of the robot's two legs. So when the robot is walking from one particular point to another point, the main problem is falling. To prevent falling, there will be a proper balance. So that means the robot will be able to maintain a balance during the walking. This balancing is essential. Otherwise, what happens is the robot will fall into the ground. So in order to prevent falling, there should be a proper balancing should be maintained. So that is what is called dynamic balancing. So the dynamic balancing is used in this Atlas robot. What is dynamic balancing? So dynamic balancing means adjusting the posture of the robot in real time to external forces. This is what is called a dynamic balancing. And another key aspect is zero moment point. Zero moment point means the point where net moment due to gravity and inertia is zero. This is a crucial aspect for stability. And the center of mass or a COM, should be within the base of support for stability. These are the key aspects related to a humanoid robot: dynamic balancing, zero moment point, and center of mass. And the stability criteria are there will be two stabilities. One is a static stability, and second one is dynamic stability. So static stability, the center of mass is within the support polygon, whereas the dynamic stability involves acceleration and inertia forces. The zero moment point must stay within the foot boundaries. When when the robot is walking from one point to another point, uh, there are different phases. For example, gait phases, stance phase, and swing phase. Stance phase means when the foot of the robot is on the ground, then this phase is called a stance phase, and if the foot is in motion, then that is called a swing phase. Okay, so in this image, you can see the stance phase and the swing phase of a human being. Same thing is applicable to robot also. If the foot of the robot is on the ground, then that is called a stance phase, and if the foot is in motion, then that is called a swing phase. And the 2D walking parameters are the step length and width, the stride frequency, the angles, joint angles of hip, knee, and ankle also are the 2D walking parameters of the robot. As I already mentioned, degrees of freedom, that means the movement of the robot. For example, consider the arm. It consists of shoulder, elbow, and wrist. So shoulder is having 3 degrees of freedom, and elbow is having 1 degrees of freedom, and wrist is having 2 degrees of freedom. Using these, with the help of these degrees of freedom, the robot will be able to manipulate the objects, different types of objects, and the robot will be able to express gestures with the help of these degrees of freedoms. And at the same time, when the robot is walking, with the help of these arm movements, the robot will be able to maintain the body balance. That means swing counterbalance during the walk. So this arm movement plays a key role for object manipulation, expressive gestures, and maintaining the body balance. Sometimes the head of the robot, okay. Uh, for some robots, maybe you saw that in the place of two eyes, there are cameras located, or with the help of that, the robot will be able to visually fixate the different types of objects. Sometimes there will be a head on the top of sorry, there will be a camera on the head of the robot. Here in this, here in this robot, you can see there is a camera here. So that the robot will be able to visually fixate on different types of objects. Uh, there are two options. One is eye mounted camera or head mounted cameras. So with the help of these cameras, the robot will be able to visually fixate the objects. And as I already mentioned, there is a head turning mechanism. So that, for example, if there is a sound, if the robot is hearing a sound from a particular location, then the robot will be able to rotate his head like human beings uh, doing. For example, if we will be hearing a sound from a particular location, we will turn our head and check what's happening there. Same thing, if there is a sound, if there is a sound is produced from a particular location, the humanoid robot will turn his head and check what's happening there. So for that, the robot needs head turning mechanisms. So the robot turn his head orient toward the sound source. So that will enhance the natural human robot interaction. Another main area is called neurobotics. Neurobotics means this is the integration of neuroscience with robotics. That means focus on brain-like control mechanisms. So that is all about the arm movement. Then next is so we discussed about the walking, and we mentioned the stance phase and swing phase, and the stability criteria and key aspects also we discussed. Next is the facial expression of the robot. So there are some robots. I will show you one robot called Mitra from a startup company, Invento Robotics. This is a startup company in India, and the name of the company is Invento Robotics. So they developed a humanoid robot that I will explain at the end of this video. I will explain some different types of robots at the end of this session. So some robots are developed. Some robots are manufactured for some particular purposes. For example, uh, specifically for hospitals or specifically for shopping complexes, etc. So that these robots can welcome the guest in a very systematic way, and these robots can guide the uh, these robots can guide the peoples in shopping complexes or in some main areas, etc. For example, in the image, you can see Indian Prime Minister Narendra Modi ji and Ivana Trump is interacting with the robot Mitra robot developed by the startup company Invento Robotics. So this is basically used for social interactions. So social interaction robot means the facial expression plays a major role major role because then only it will improve the emotional engagement with the users. So in order to improve the emotional engagement with the users and enhance social interactions, the robot, that is the facial expression of the robot, is a very key point. There are actuators behind the artificial skin or flexible material. So on the face of the robot, there are artificial skin or flexible materials are provided. Behind the artificial skin, there are actuators provided. So, so based on the command received by the actuators, then the actuators will move accordingly so that we feels that the robot is smiling or the robot is blinking his eyes like that. So the facial expression is very important so that that will improve the emotional engagement with users. Uh, the humanoid robots' hands looks like human beings, usually equipped with the fingers and with the multiple joints. And at the end of the fingers, there are sensors provided. So to provide feedback, the sensor will give a proper feedback because that is essential for the proper operation of the robot in a particular environment. There are sensors in the fingertips provided. For example, it can sense the touch, it can sense pressure, etc. And with the help of these fingers, the robot will be able to grasp different types of objects, different shapes that these robots can grasp. And of course, the robot will be able to grasp different objects with different weights. Also, the robot will be able to grasp. And of course, the robot will be able to do writing, lifting, assembling, etc. Some robots will be able to speech in front of the people. So text-to-speech engines are used. Voice modulation makes communication more natural. So that is also possible in the case of humanoid robots. There are different types of actuators used in robots, such as electric actuator, hydraulic actuator, and a pneumatic actuator. So as I already mentioned, Atlas Boston Robotic, this is completely electric. This is completely fully electric robot. But previously, there are other actuators also, such as hydraulic and pneumatic. Hydraulic means hydraulic actuators are used for heavy-duty humanoids. And previously hydraulic actuators are used in Atlas, but nowadays they are using completely electric actuators because they need high precision. Pneumatic actuators providing smooth movement, but the precision is not good comparing with the electric actuators. Hydraulic actuators are used in heavy-duty humanoids. When we are going to manufacture a robot, what are the things we should consider? The first of all, the thing is that the weight should be minimum. Okay, the weight of the robot is lightweight. At the same time, the lightweight plus at the same time strong materials we should be used. For example, aluminum, carbon fiber, etc. we can use. And the joint torque capacity and the range of motion we should consider, and how compact the robot is. The compactness is very important, and how energy efficient the robot is. We should consider the energy efficient also. When we are going to manufacture a robot or when we are going to design a robot, we should consider these factors. First of all, the material. This should be lightweight, but at the same time, we can't compromise the strength of the robot because the robot will be working in a different environment. So we should use strong materials. We can use aluminum or carbon fiber we can use. And the joint torque, these joints torque capacity is again another factor. And the motion, the range of motion, and the compactness of the robot, and finally the energy efficiency of the robot, how efficient, how energy efficient the robot is. There are tactile sensors. In order to sense, there are tactile sensors provided in the robot that will emulate human senses of touch. And these tactile sensors are provided on hands, feet, and body of the humanoids. There are various types of sensors such as capacitive sensor, resistive sensor, piezoelectric sensor, optical sensor, etc. So because of this tactile sensors, this sensor will touch in with touch in the object. So contact with the object. That means detecting contact, and this tactile sensors will be able to measure the pressure, shear force, texture, and also these sensors will be able to recognize the shape also. So next, I will show you a robot from. I will show you few robots uh, from different companies. First of all, I will show you an entertainment robot called AIBO. So this is actually an entertainment robot from a Sony company. This is the behavior is like a dog-like behavior. This is purely an entertainment robot. Okay, so this AIBO, this robot is from Sony, and the name of this robot is AIBO, robotic puppy powered by artificial intelligence. This is a research prototype for dynamic biped locomotion, and this robot is equipped with a camera, gyros, and wireless communication. Okay, so I will show you a video of AIBO. So this is actually a robot. This is an entertainment robot with a dog-like behavior. So what's new? Okay, let's see some specifications. Where is that? Yeah, this is the specification of AIBO. This is purely an entertainment robot. Head, there are 3 degrees of freedom. Mouth, 1 degree of freedom. And neck, 1 degree of freedom. Waist, 1 degree of freedom. Front, pose, back, pose, 3 degrees of freedom. Ears, 1 degrees of freedom. Tail, 2 degrees of freedom. Total, 22 degrees of freedom. As we already discussed when we start this video, degrees of freedom. Degrees of freedom means the movement, the motion. So in this robot, there are 22 degrees of freedom. There are different buttons and switches, such as power button, volume button, network switch. A status LED, network LED is there. Displays OLED is there, eyes for two. There is one front camera and a slam camera. Terminals, charging pins, and a SIM card slot is there. Speaker for sound, speaker and microphones provided. There are various sensors provided, 6-axis detection systems, then motion sensor, ranging sensor, TOF sensor, light sensor, head sensor, capacitive type touch sensor, jaw sensor again, capacitive type touch sensor, back sensor, and 4 parts. The power consumption is approximately 14 watt, and the battery life is approximately 120 minutes in standard mode of operation. And the dimension is 180 by 293 by 305 millimeter. And the total mass of this AIBO is 2.2 kilogram. And the communication system is mobile network communication feature, LTE, and Wi-Fi also. Okay, so that's all about the robot called AIBO. And another robot, this one we already discussed, that is called ASIMO. ASIMO is a humanoid robot developed by Honda. This is basically for human interaction and walking research. And this humanoid robot will be able to run, climbing stairs. Where is that image? There is one image so that uh, the ASIMO robot is climbing stairs. Yeah, so this one. So the robot will be able to climb stairs, and the robot will be able to carry different objects, and this will be able to recognize various gestures, etc. And this is using ZMP based walking and stereo vision. This is actually a robot from Honda company, ASIMO. Another one is Hiroshi Hiroshi Ishiguro's face robot. And this is basically designed for realistic facial expressions and human-like conversations. And this robot mimics human facial movements using pneumatic actuators. And this is used in emotional interaction studies and social robotics. Another one is the last one. The last one is called Mitra robot. This is a startup company. This is developed by from a startup company uh, named Invento Robotics. The startup company is in Bangalore. Is founded by Balaji Vishwanathan, and they developed this Mitra robot. And this is again a humanoid robot. This is from an Indian startup company. This image is showing. This is a news from Times of India. This image is showing Made in India robot Mitra becomes Modi's friend. So there is a video I will show you. So that's all about uh, the basics of humanoid robots. So we discussed about what is a humanoid robot and what is the difference between autonomous robot and humanoid robot. And then we discussed about various types of the history, the evolution of robot starting from 1920s. Elektro, we discussed about Elektro, HRP series, ASIMO, then Atlas from Boston Dynamics, so and so. Then we discussed about uh, an entertainment robot named AIBO from Sony company, and finally we demonstrated uh, the robot from an Indian startup company named Mitra, and the name of the robot is Mitra, and it is from an Indian startup company, Invento Robotics. So, so I am stopping my session by showing the video of Atlas from Boston Dynamics. Okay, so have a nice day. Thank you for watching my video.